At Checkly, we're always trying to help our users find and resolve issues 10 times faster. And the OpenTelemetry project wants to enable more observability with open standards. I'm excited to share Checkly Traces, our new tracing solution built on OpenTelemetry, and how it can help you find the root cause of problems in real time. Checkly's monitoring system performs regular checks against your service, using the power of Playwright to automatically monitor your web app or API. Synthetics are the best way to know if your service is truly available to your users at any given time. Before Checkly Traces, a failing synthetic check often required investigation by your team to find out what internal components might be failing on the back end. For many of us, that can mean looking at the time the synthetics check failed and manually trying to correlate that with back-end trace information from the same time. This isn't a fun or a smooth experience, especially during a downtime incident. Checkly Traces provides a clear, immediate view of your traces in every synthetic check run, both on the back end and front end. We handle the correlation for you, helping you pinpoint the root cause faster without the need to manually correlate or look up data in third-party observability systems. After instrumenting your application, back-end traces will be sent to Checkly, and the Checkly service will correlate these traces with the results of our synthetics monitor. In just a minute, I'll show you how to configure your OpenTelemetry collector to send traces to Checkly. The result is a synthetics check that not only detects problems right away, but already has all the information you need to get to the root cause. This works in monitoring from the browser and API monitors. Here you don't just see the exact request and response, but the exact post-REST query and its performance on the back end. You don't need to go and find a correlation because we'll do it for you. By only recording the interactions we generate, we minimize data volume and storage costs, making observability more economical and manageable. Finally, we've added the ability to emit our Checkly results to your third-party collector as spans. Add synthetic data to services like New Relic, Dynatrace, Honeycomb, and others. This adds data on front-end performance to your existing APM tools, and the spans are clearly marked for easier correlation. By focusing only on the tracing data that correlates, teams can filter out unnecessary information and focus on the most critical data points. This ensures that both development and operations teams can zero in on the telemetry that directly impacts key business processes, reducing noise and improving overall efficiency. Let's get started sending our OpenTelemetry trace data to Checkly. Okay, so this is our goal. We want a trace like we're familiar with for one of the Checkly checks. And along with the test runner information that we get here for each component that executed, we also want to be able to see some information about what's happening on the back end. As we scroll down, we see we have our OpenTelemetry trace in here. And we're actually able to see what's going on within the application, including things like what method names are being called and span attributes from that backend application. So how do we get here? The beauty of the OpenTelemetry collector is that we don't need to install a special agent on the backend to get this information. Provided we're already using the OpenTelemetry collector, we can just configure it to send this information on to the Checkly Traces API. Okay, let's configure our Checkly account to send this information. We'll go into the Traces beta and we'll hit Settings. Then we'll turn on Import Traces and we'll generate an OTel API key. This will automatically turn on HTTP instrumentation for our synthetics checks, which will add the trace parent and trace state headers, which will create the right context to correlate with backend traces coming from our application. So now that we've got our API key, we're going to open up the configuration for our OpenTelemetry collector. It's the point where we want to export the traces that were started by a Checkly synthetics check. Okay, so we're going to add two components to this configuration, and I'm not going to do this live. I went ahead and added these to the YAML, but we're going to step through them as well. So everything heretofore has been totally standard. This is just my demo setup for this running OpenTelemetry install. But then under exporters, we've created a stanza for Checkly. We're doing this via the OTLP standard or protocol. We give it the endpoint address that we got from the settings. And of course, you can find all this in our documentation. And then we've given it that authorization key, and I've blanked mine out for this example. Next, we've added a processor filter. What this is doing is ignoring any span where the trace state is not set to be checkly. So this means that this is going to filter out any traces that we're seeing that were not kicked off by a checkly synthetics request. So now that we have our filter and our exporter, we just need to add this to the pipeline. So down here, we'll create a second pipeline, right? Because we want our traces to go out to our normal New Relic, Datadog, wherever else, endpoints, or maybe our Prometheus Grafana, self-hosted endpoint. We want those to go out as normal. So we're going to set up a second pipeline here where we have it hit the checkly filter and then goes out to the checkly exporter. With the collector configuration updated, we just need to go ahead and restart the collector. And then it'll pick up that new configuration detail. And now we can look for some OpenTelemetry traces. So here I have my simple application. It's a dice roller app, as you might be familiar with from the OpenTelemetry demonstration docs. And we can go ahead and send requests into it. They come back nice and quickly. But if we send a request for a few more dice, it can come back very, very slowly indeed. So you get a lot of latency here. And so we've created a check over here. We can take a look at the code that underlies it, which is just going in and just saying, hey, is this available within the timeout time? And when we take a look here, we can see that sometimes this is working okay, but that very often we're getting back bad responses. We're not 100% sure why, what's changing, and why is this check failing. So let's take a look at one of our failed checks. So along with really full detail about the geographies where this is failing from, the response that we're getting back, we're able to see the full test report step by step as it goes in. We're also able to scroll down here and take a look at the OpenTelemetry trace on the back end. So we're able to see both the middleware that gets at the request handler and the actual class that we're using that appears to be taking up a big chunk of the time. And so a bunch of these dice rolls seem to be taking no time at all, until one of them includes a big section of arctan methods of all things. And so what it turns out when we investigate this application, most of the time it just rolls dice as expected, but on certain values, it goes through and attempts to calculate pi to a large number of digits. So that, no doubt, is the cause of that slow performance. With that method updated, we'll see that these checks have started to succeed. And that's been Checkly Traces. If you want to get more detailed, take a look in our documentation, which has guides for instrumenting multiple different frameworks and languages, how to send data in multiple formats, and also how to get data out to your third-party APM solution. Thanks for checking it out.